And welcome back, guys. Sorry about the mess for the bed. I am reading pages 81 through 86 of Machine Learning by Tom and Mitchell. And it goes into artificial neural networks, or ANNs. So, as an intro, neural networks are a form, an algorithm that has a um, what's the term they use? An acyclic feed-forward network, meaning it doesn't go in loops. It goes from what are called perceptrons that take input and feeds it to other perceptrons and until you get a final output. And the reason they call them neural networks is because it's somewhat similar to how the brain works. So you have a lot of neurons in your brain, and each neuron feeds into other neurons, and together they work together, each having its own job, I guess you could say, to help you make decisions, help you do things. So neural networks work in the same way. So yeah, it talks about how neural networks got started. Like there's two different groups of I guess people researching them. One is how neural networks compare to the biology of the brain, and the other one is, which is what we're doing, trying to create algorithms to solve problems. Basically, what a neural network, I'll explain it again, but what a neural network does is it's got a bunch of perceptrons that take things like, for example, in this book, self-driving cars. Take the pixels of whatever the camera on the car is seeing, and feeds it to perceptrons. And each perceptron, I think, at least in their example, is a linear combination, at least in the back propagation algorithm, is a linear equation. So it's basically, it has a weight and the input, and it combines all those together, adds those all together, and to either output 1 or -1, or depending on the algorithm, a value between 0 and 1. Either to, if it's between 1 and -1, it's either to say, okay, this decision goes forward or this decision does not. Or if it's between 0 and 1, it's the confidence level that decision should be used. If I'm understanding this correct, hopefully I've understood this correctly. Appropriate problems for neural networks are any problems where it's well suited. So neural networks is well suited to problems in which training data corresponds to noisy, complex sensor data, like for example, cameras and microphones. So if it has the following characteristics, it's suitable. So instances are represented by many attribute value pairs. Basically, if you have a lot of attributes, you can use a neural network. The target function could be discrete valued, real valued, or even vector or several real or discrete valued attributes. Basically, it can work with all, values. So there's that. Training examples may contain errors, so it can work with that. Long training times are acceptable. Normally the problems it's trying to solve, you need a quick evaluation of the learned target function. So for example, self-driving car, you don't have time for it to, more than a split second for it to make the decision. And we don't have to understand the learned target function. It's not important. The representation of these target functions are usually not easy for us to understand. So there's that. Yep, and then it goes into what a perceptron is, and it's basically a single unit within the algorithm that takes in an input and outputs an output. Now that output may or may not be seen by the algorithm, if that makes sense. Like if it goes to another perceptron, then it's what's called as hidden. If it goes to the direct output, then it's not hidden. That's pretty much it. Simpler than I thought it was going to be honest. But yeah, it's just the intro. So there's that. Thanks for watching the video. Hopefully that helped. It helped me a lot. So that's really why I'm making these videos.